In this video I'll solve question 2 of the Cayley Olympiad paper from 2022. The Cayley Olympiad is sat by students who've done really well in the UKMT's Intermediate Maths Challenge. It's aimed at students in Year 9 in England and Wales, or students ages 13 to 14 if you're comparing with other parts of the world. Depending which year group students are in and how well they've done, they might progress to either the kangaroo rounds or the Olympiad rounds, can be the grey or the pink kangaroo, or the Cayley, Maclaurin or Hamilton rounds, depending what year group they're in. These are some of the most challenging problems for students of this age group, and unlike the Intermediate Maths Challenge and the kangaroo rounds, the Olympiad rounds do require students to give full working in their answers. So this question would be worth 10 marks in the Olympiad round. The best way to practice for these competitions is to head over to courses.mathsaurus.com, where you can try one of my free preparation courses. So you can work through this question and all the others in this paper with video hints as well as solutions, and there are also courses for the Intermediate Maths Challenge, for the kangaroo, for the junior and senior rounds, and loads more over there as well. So do head over there, totally free to sign up, no payment details are required to access these free courses with the UKMT questions. So I hope to see you over there at some point, but for now let's get on with this question right here on YouTube. Please do like the video and subscribe to the channel if you haven't already. So we want to find all of the palindromic numbers that have 6 digits and are divisible by 45. Now 45 has been chosen here because it's quite a nice number to work with in terms of divisibility, because if a number is divisible by 45, it's also divisible by 5 and by 9, and we can say that's true because they don't have any factors in common, right? I can't say a number is divisible by 3 and 9 just because it's divisible by 9 or something, right? Or even by any two numbers that have factors in common. But like if you have 5 and 7, right? If they're divisible by 5 and by 7, they're definitely divisible by 35. And if it's divisible by 35, it's definitely divisible by 5 and by 7, because 5 and 7 don't have any factors in common. So, let's just give this number a name, right? Let x be a 6-digit palindromic number. Then, right, we can say, okay, let's also just say divisible by 45. Again, you might want to add a few extra words into your answers compared to what I write up here. So then x is divisible by 5. Okay, and I'm going to leave a little gap here. And x is also divisible by 9. Now, you should know the tests for divisibility by 5 and by 9. I've talked about them a lot in these videos and in the answers to questions here in the free courses, and also in my Go for Gold courses that that go into a bit more depth about some of these topics. But if number is divisible by 5, this means that the last digit of the number is either 5 or 0, and something being divisible by 9 means that its digit sum, right, which is what I get when I add all the digits together, is a multiple of 9. Okay. Now, it's useful, because we're talking about a palindromic number, to be able to talk about each of the digits in the number. So actually, when I say let x be a 6-digit palindromic number divisible by 45, let's also say let x be equal to ABC CBA, right? So it's going to read the same forwards as it does backwards. And in the context of this question, it's clear we don't mean A times B times C times C times B times A here, right? It means the digits, but you could say something to make that clear as well if you want. Okay, if the last digit is 0, then it's a 5-digit number, right? So actually, the only option here is that for it to be divisible by 5 is for it to end in 5, and that means that in this number, A is equal to 5. So what we need is that this number, ABCCBA, which is now 5BCCB5, we need that to have a digit sum, which is a multiple of 9. Sometimes repeating things rephrased just slightly more simply in maths is quite helpful, right? And actually, if you keep doing that, you sometimes realise you just got to the answer without knowing it, right? To have a digit sum of a multiple of 9, right? So if I turn that into an algebraic statement, that means that 10 plus 2b plus 2c is a multiple of 9. Okay. Now, fine. Now at this point, we've kind of run out of ideas. And a skill in the Olympiad problems is knowing in these sort of combinatoric-y kind of questions where there's lots of like options and things we've got to consider, is like, when do we just go to a brute force method, right? When do I just give up trying to be clever and just start checking all the options? And in this question, this is exactly the right point to do it. So what we're going to do is just go through the numbers in order, right? So we're going to say if b is equal to 0, right, then we need, so then this becomes 10 plus 2c, I'm not going to keep writing, is a multiple of 9. Let me just write like equals times 9 or something, maybe that sums up what I'm trying to write here. And so the only actual option that would make this work is to make c equals 4, and to make this 10 plus 8 is 18. So this means c is equal to 4. And, you know, we can't, well, the multiple of 9 below that is just 9, that clearly doesn't work. And if I go up to 27, I'd need 2 times c to be 27, so 2 times c to be 17, so that's not going to give me a whole number for c. And if I go beyond that, I'm going to go outside of the range of digits from 0 to 9. So we just get that as the option, and then we just go through all the others doing the same thing, right? So if b is 1, then this statement is actually 10 plus 2b, so I've now got 12 plus 2c needs to be a multiple of 9, and I can only do that by making c equal 3. I'm not going to go through that full logic every single time, but, you know, again, 12 plus 6 is 18, and there are no other options. And if we keep doing this, right, you know, if b is 2, then I've got 14 plus 2c is a multiple of 9, and then c is 2, and that gets me to 18 again. If b is 3, then it's 16 plus 2c is a multiple of 9, and the only way to do it is c equals 1, b equals 4. I've got 18 plus 2c is a multiple of 9. Now this time, I can have c equals 0, so just stick with 18. This time, if I go up, okay, 27 still doesn't work, but 36 now does. I can have 2 times 9 is 36, so I actually get c is equal to 0 or 9. If b is 5, I've got 20 plus 2c is a multiple of 9, and now I've got to go up to 38 to make this work. Sorry, to 36 to make this work. I think I said 36 before as well, hopefully. So c is equal to 8. That would work. b is 6. I get 20 plus 2c is a multiple of 9. Sorry, not 20. Going too fast. 22 plus 2c is a multiple of 9. And that gives me c equals 7. Almost there. b is 7. 24 plus 2c is a multiple of 9. So to get to 36, this time I need c equals 6. Sometimes as you go through, you spot patterns as well. You can see like the c's that I'm just going down 4, 3, 2, 1, 0 or 9, and then 8, 7, 6. And this is going to keep going. You can sort of see why it does here in the structure. But we get c equals 5 here, and then finally for b equals 9, I've got 28 plus 2c is a multiple of 9, and I get c equals 4. And I think all and now we've exhausted all the options. So it was a bit hard work, it was a bit boring to go through all those one at a time, but, you know, important to know that we can just do that. There's only, you know, 10 things to check. So I think the final thing to do here is just to list out the possibilities, right? So the possibilities are, and I can just go through all these options and fill them in now. So for the first one, when b is 0, c was 4, so I get 5, 0, 4, 4, 0, 5, right? When b is equal to 1, I had 5, 1, 3, 3, 1, 5, and then I've got 5, 2, 2, sorry, 5, 2, 5, 2, 2, 2, 2, 5. I've got 5, 3, 1, 1, 3, 5. Got to be very careful writing these down. I've got 5, 4, 0, 0, 4, 5. I've got 5, 4, 9, 9, 4, 5. I've got 5, 5, 8, 8, 5, 5. I've got 5, 6, 7, 7, 6, 5. I've got 5, 7, 6, 6, 7, 5. I've got 5, 8, 5, 5, 8, 5. And I've got 5, 9, 4, 494. Forgive me if I made a typo in any of those, I hope I haven't. But I do think it is important at the end that we do actually state the answer to the question, and if you've got a clear answer like that and they can see the workings good, you're very likely to get all the marks here. I mean, the markers for the Olympiad do always read all the options carefully, but when you see a well laid out answer with the correct answer at the end, it's very easy just to give it 10 marks and to move on, I think. So there we go, that's question 2. Again, another tricky question, interesting as always, and so well done if you got that right.